Very good morning. Welcome to the session. Myself Dinesh. So we are talking about communication systems, a topic called random variables. So I'm taking 6 sessions based on topic called random variables. So this is a second session on random variables. So yesterday I've taken the first session. So today is the second session. So if you have missed yesterday's session, I've talked about probability density function. You can go through that class. Right. So this is the second session and 4 more sessions are there which I'll be taking on random variables. So multiple concepts based on random variables will be discussed in this week. So every day class is at 8 a.m. Right. So let's start with the session. Okay. Okay. So here is my profile. So I teach these two subjects, communication systems and signals and systems. So this is my Telegram group. So if you wish to ask me any doubts based on communications or signals, so you can post it in this group. I can help you guys. Okay. Right. So coming to what is the agenda of today's session. So what I'll be discussing in today's session is, so first I'll be discussing, I have given some homework questions in yesterday's session. Yesterday's session is based on probability density function. So I've given 2 questions for your as homework. So I'll be discussing the solutions for those questions initially. And after that, we'll move on to cumulative distribution function. I'll explain what is cumulative distribution function. So what is the meaning of it? Okay, how do we plot it? So we'll take some examples, some random experiments as examples to understand cumulative distribution function. And later, we will understand the relation between PDF and CDF. PDF means probability density function. CDF means cumulative distribution function. Okay, right. And then we'll solve some questions based on cumulative distribution function for better understanding. And at the end, I'll be giving you some homework questions as well. Okay. So let's move on to the next slide. So these are the 2 homework questions I've given in yesterday's session. So let us solve them quickly and we'll move on to today's topic, cumulative distribution function. So a discrete random variable x takes values 4, 5, 6, 7 with equal probabilities. See this one? X is taking 4, 5, 6, 7, 4 values with equal probabilities. If 4 values are having equal probabilities, then the probability of this, let me say the probability of 4, x equal to 4, is same as probability of x equal to 5, which is also same as probability that the random variable takes a value of 6, which is also same as probability that random variable takes a value of 7. That is the information given. See that random variable takes 4, 5, 6, 7 with equal probabilities. This is what they are saying. Let me say this value is small a. Okay, you can take some other value, some other letter also. If you observe, we know the properties of probability. Probability value of any particular value of random variable or probability of any event lies between 0 to 1. Okay, it lies between 0 to 1. And second property of probability is the total probability of all possible values of random variable. If you add them up, the total probability will result in 1, right? So the probability of 4, the probability of x taking value 4 plus probability of x taking a value of 5 plus probability of x taking a value of 6 plus probability of x taking a value of 7, because they said that random variable takes only these values with non-zero probability. So when you add up these probabilities, that should result in 1. Since it is given that they are all equal, so we have denoted it with a, so we can substitute a here, a here, a here, and a here. So it is a plus a plus a plus a, 4 a's, it is equal to 1. So 4a equal to 1, a equal to 1 by 4. So the probability of each of these values, probability that the random variable takes each of these values, is only 1 by 4. So this is actually direct step. We can easily tell whenever next time when you are seeing a question, if there are 5 values that the random variable is taking with equal probabilities, then the probability of each value is 1 by 5. Okay. If it is taking 6 values, then the probability of each value will be 1 by 6. Okay. Very simple. When they're saying equal probabilities, it is easy to figure out the probability of each value. Or you can go with this procedure if you are having any confusion. Okay, this is an easy thing to figure out. Okay, but that is not the question. They're not asking us the probability of each value. That would be a very easy question if they ask. So they're asking us to find what is the probability that x takes values greater than 5. What is the probability that x takes a value greater than 5? Greater than 5. It's not equal to. Equal to is not there. Mind this. When they're talking about discrete random variable, equal to is there or not. That is very important. For when you're talking about continuous random variable, whether there is an equal to or not, that should not matter much. Very rarely it will matter. When there are impulses in the PDF. When there are impulses in the PDF, only then equal to is there or not will matter. Whereas in discrete random variable, equal to is there or not will matter. Okay, always. So x greater than 5 means we are interested in the values of x greater than 5, which means 6, 7. Because it is discrete, we are interested in the values of x taking values 6, 7, 8, 9, 10 and so on till infinity. So here we are interested in values of x, which is 6, 7, 8, 9 and so on. But only 6 and 7 are taking, x is taking 6 and 7 with non-zero probabilities. 8, 9, 10 on all those values, it is taking with 0 probability. So what is important for us? Only 6 and 7 is important for us. That is why I'm writing. Actually, we are interested in 6, 7, 8, 9, 10 till infinity. But since it is taking only 4, 5, 6, 7, among these 4 values, what values are we interested? According to this condition, x greater than 5 means we are interested only in 6 and 7. Plus probability of x less than or equal to 7. Less than or equal to 7 means we are interested in all values of x less than or equal to 7, which means 7, 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2 and so on. All of those values. But among the values that we are interested here, what are the values that are having non-zero probability? All the values 4, 5, 6, 7 are having non-zero probability, right? So what values are we interested here? X less than or equal to 7 means we are interested in 7, 6, 5, 4, 3, 2, 1 also we are interested, but since they are not having the non-zero probability, 3, 2, 1, all these values of x are having 0 probabilities. So that's why we write only these, which is equal to. What is the probability of 6 and 7? Probability of 6 is 1 by 4. Probability of 6 is A, which is 1 by 4. Probability of 7 is also 1 by 4. So it is 1 by 4 plus 1 by 4 is the probability of this part. And how about the probability of the next part? Probability of the next part is probability that x takes a value 7, 6, 5 and 4. What is the probability that x takes a value 7? It is 1 by 4. Probability that x takes a value 6 is also 1 by 4. Probability that x takes a value 5 is also 1 by 4. Probability that x takes a value 4 is also 1 by 4. Totally how many 4s? How many 1 by 4s? So it is 6 1 by 4s. So finally the answer will be 6 times 1 by 4, which is 3 by 2. So that is the answer. Hi Rahul, good morning. I think I remember your name correctly. A continuous random variable x takes values 4 to 7 with equal probabilities. Mind this, we're talking about continuous random variable. So they're taking the random variable is taking values 4 to 7 with equal probabilities. So we can plot the PDF, right? For a continuous random variable with equal probabilities, it is said that it takes values 4 to 7 with equal probability. Okay, so what is the height? We know this is PDF. Let me say this is fx of x as a function of x. So this is the PDF. This information is given in the question. Based on that information only I have plotted this graph. We know any PDF, properties of PDF is its value should be always positive. This PDF function, this probability density function should never take a value negative, should never take a negative value. Okay, that is the first property. Second property is the area of PDF should be equal to 1. So since we have plotted PDF here, its area should be 1. If you want this area of this one should be 1, what should be the height? Anyone? What should be the height here? What is the height of this PDF so that the area will be 1? This is a rectangle. You want the area of rectangle should be equal to 1 because why should the area 1? Because we are saying that this is a PDF function. So PDF, anybody says PDF function, its area will be 1. If its area is not 1, then it is not a PDF function. So for the area to be 1, how much should be the height? Anyone? Since the width is 3, height should, how much should be the height so that the area is 1? Height should be 1 by 3. Width is 3. If height is 1 by 3, then 3 into 1 by 3 will become 1. Okay. right? This is the PDF. So they're asking us to find what is the probability of x greater than 5. So what are we interested in? We are interested in all the values of x which are greater than 7. We are interested in all the values of x greater than 5. See here. So we have to add up the probabilities of the random variable taking values greater than 5. So add up the probabilities of 5.1, 5.2, 5.3 and so on till infinity. We are interested in all the values of x greater than 5. If they have given equal to also, it should not matter, but the answer will not change. Okay, in continuous PDF, when there are no impulses, whether they give equal to or not, that will not change the answer. Okay, so x greater than 5 means we are interested in the probabilities of x taking values 5 and more than 5. So this probability, this probability, this probability, all of them we want to add. Because this is continuous graph, we have to take the area. To find the probability of all these values, we just need to find the area of the PDF starting from 5 till infinity. From 5 till infinity, let us find the area. What is that area? This area. After 7, there is no area to find. So that's why this is the area that corresponds to probability of x greater than 5. Whenever they're asking us to find the probability in for a continuous random variable, it always indicates area in the PDF graph. In the PDF graph, the probability always indicates some area or the other. Next, how about p of x less than 7, less than or equal to 7? Let me take a different color. So probability of x less than or equal to 7 means we are interested in all the values of x from 7 to minus infinity. See, all these values we are interested. Okay, all these values here we are interested. So to find the probability of all the values of x from minus infinity to 7, find the area of the PDF graph from minus infinity to 7. So find the area from minus infinity to 7. So from minus infinity till 4, there is no area at all. From 4 to 7, there is an area. So this total area is what we are interested in. So whatever is in blue, that indicates p of x less than or equal to 7. So what is this a value? P of x greater than 5. How much is it? X greater than 5 means this part of the area, the yellow area. How much is that? 5 to 7. The width is 2 units. The width is 2 units. Give me a second. Yeah. P of x greater than 5 means P of x greater than 5 means this area. If you want to find this area, this looks like a rectangle with a width from 5 to 7 and height of 1 by 3. From 5 to 7, the width is 2 units. Width is 2 units. And what is the height? Height is 1 by 3. So that is the area of P of x greater than 5, this part. Next, let us find the area of P of x less than 7. X less than or equal to 7 is including all the area of the PDF graph. All the area of, we know that the total area of the PDF is 1, right? We know that the total area of the PDF is 1, or this total area, width is 3, height is 1 by 3, area is 1 unit. So this is 2 by 3 plus 1. How much is that? It is 5 by 3, no? It is 5 by 3, right? Is that okay? I hope you're following. Okay, let me ask you one more question here. Okay, so what is the probability that x takes a value 5? How about that? Can anyone answer me this question? Whenever they're asking us about probability for a continuous random variable, always understand it in terms of area. So 5, look at it as 5 minus less than x less than 5 plus. Is that okay? So find the area from 5 minus to 5 plus, this area. This is the area that we are interested in. How much is this area? So 5 minus to 5 plus, the width is almost 0 value multiplied with height is 1 by 3. What is the area? This is almost 0 value, infinitesimally small value multiplied with 1 by 3 is almost 0 value, infinitesimally small value. Is the probability for 5 0? The probability that random variable takes a value 5, is it 0? Strictly speaking, it is not 0. It is some small value. It is some very small value. Is that okay? I hope it is clear till this point. So I'm moving ahead to the next slide. So homework questions which I have given in yesterday's session are done. So let's move on to today's topic, which is cumulative distribution function. So guys, this is very important topic. So you have to focus very well. So So I've written the definition like this: a function with information of probabilities. This cumulative distribution function, in short, we call it a CDF. The notation generally is taken as capital Fx of x. That is the notation if x is the random variable. If y is the random variable, you take it as capital Fy of y. Okay, that capital F letter is what we use generally, but that does not mean that we have to use only letter F. We can use letter G, we can use letter, any letter is fine, but generally we use capital F. Okay, somebody gives using some letter capital H, does that mean that it is not CDF? No. CDF function means you can use any notation. There is no strict criteria that you should use only capital letter. You can use small letter also, but generally we follow a notation of capital letter for CDF and small letter for PDF. But notations can be as per the person giving the questions. Okay, but this is the notation that we follow generally. So, or sometimes they also follow this notation also. Any notation is fine. Somebody says PDF or somebody says CDF, we know their properties. Okay, yeah. If somebody says PDF or CDF, we know their properties and we have to apply those properties. What is the notation? That is not really important for us. Okay, but generally we use this notation. Right. So the CDF function, it is a function. That function, what information does it have? It has information of probabilities. PDF function and CDF function both have same information. Both have same information. That information is about probabilities. But the information is arranged in different ways. Otherwise, we don't need two different functions, right? To indicate information of probabilities, we're having two functions. One is PDF, another one is CDF. Both have same information of probability, same information, exact same information, but they're arranged in different formats. So this has information of probabilities of particular values, whereas this has probability of accumulated values. The difference between these two functions is both have same information, but they are arranged in different formats for convenience. Okay, right. So a function with information of probability. This is also a function with information of probabilities. PDF is also a function with information of probabilities. But in CDF, the information of probabilities is in accumulated form. What is the meaning of accumulated form? I'll explain. Okay, it is an accumulated form. So accumulated means what? Accumulated means some kind of added. Accumulated means I have accumulated a lot of stuff, means I have added a lot of stuff. I have taken a lot of stuff and I have accumulated. Accumulated means the meaning turns out to be addition. Right, let me explain in detail. Capital Fx of x. What is the definition for this? Let me explain the definition. Probability that, let me take this value as x naught just for convenience, x naught instead of x. The meaning of this is when somebody is talking about CDF function, CDF function value at x naught. What is the meaning of it? It is the probability that the random variable takes values of x less than or equal to x naught. So CDF function indicates not the probability at x naught. It is not indicating the probability at x naught, but the probability till x naught. Till x naught. For example, I'll take some examples and I'll explain. Okay, let me explain this first. As a function of x, if you're having PDF, okay, if you're having PDF, okay, so if you're having PDF indicates the information at that point. Probability at a particular point is indicated by PDF. Okay, for example, I'll take some discrete PDF just for explanations. Okay, 1, 2, 3. So the height is 1 by 3, 1 by 3, 1 by 3, something like this. Okay, a simple example I'm taking. So this PDF for a discrete random variable is indicating the probabilities at that points. At 1, whatever is it is indicating, it is a probability at 1. Here, whatever is the value, that is the probability at x equal to 2. This value is the probability at x equal to 3. Okay. Whereas, what is the CDF indicating? Let us plot the CDF also according to this definition. Capital Fx of x. If you plot it at x equal to minus 5, what is its value? At x equal to minus 5, at x equal to minus 5, if you put minus 5 here, you want the value of this function at minus 5. Put minus 5 here. If you put minus 5 here, just substitute and understand. I'll take substitute different values so that you will understand it better. Once you understand the meaning of CDF, then it will be very easy function to analyze and solve questions also. CDF is more comfortable to solve problems than PDF, relatively. Right. So fx of minus 5. What is the meaning of it? You are interested in not in the probability of x taking minus 5, but you are interested in the probability of x taking values less than or equal to minus 5. Less than or equal to minus 5. See this one? Till minus 5. Till minus 5, whatever values of random variable are there, all these values, you are interested in the probability of all these values. CDF at minus 5 indicates the probability. CDF at minus 5 indicates the accumulation or addition of probabilities of all the values of random variable till minus 5. Add up all the values of all the probabilities till minus 5. It is 0. There is nothing here. Similarly, till at 0. This function's value at 0. If it is 0 here, it will be 0 here. You are interested in the values of the random variable from minus infinity to 0. If you accumulate all the values till 0, it is 0. So this function indicates at this point, it is accumulation of probabilities till that point. In the PDF, it is accumulation of probabilities till that point. Okay, similarly, 0.9 till 0.9. Till 0.9, what is the accumulation? The accumulation is only 0 till 0.9. Okay. And at 1, what is happening? At 1, what is happening? At 1, just at 1, there is something to accumulate. There is something to accumulate. What is the meaning of this? Try to understand the meaning of this. Fx of 1. What is the meaning of fx of 1? The meaning of this is probability that x takes a value less than or equal to 1. The meaning of this is accumulate all the probabilities of the random variable taking values less than or equal to 1. So till 1, whatever are the values of the random variable from minus infinity till 1, whatever are the probabilities of the values of the random variable, just add them up or accumulate them. So keep on adding 0 plus 0 plus 0 plus 0 till 1, it is 1 by 3. All zeros plus 1 by 3 is 1 by 3. So the height is 1 by 3. Next, at 1.1, what happens? At 1.1, the value, if you want the value of this function at 1.1, find add the probabilities of the random variable taking values from minus infinity till 1.1. Till 1.1, if you add up all the probabilities, that is also 1 by 3. Correct? Similarly, till 2, just before 2, if you add up the probabilities till that point, till any point between 1 and 2, it is the same thing, which is 1 by 3, because there is only one value to accumulate from 1 to 2. Okay. But at 2, what happens? Put value 2 here. Put value 2 here. If it is 2 here, it is 2 here. Okay. Fx of 2. This function's value at 2. This function's value at 2 is the probability of a random variable taking values less than or equal to. Less than or equal to. So probability that the random variable takes values from minus infinity to 2 included. In CDF, we always that there is an equal to sign. Whatever value you are seeing here, that the probability of that value also should be included. Okay. So till 2, if you add up all the values, what is it? It is 1 by 3 plus 1 by 3 plus remaining are zeros. So it will become 2 by 3. It will become 2 by 3. Next. Till from 2 to 3, there is nothing to accumulate. At 3, there is something to accumulated. So it will become 1. So what is the height finally? 1 unit. Final height is 1 unit because as you keep on accumulating, the total probability is 1. So in the PDF, so here you see here from minus infinity. From PDF, it is very easy to plot CDF. Observe the meaning. From minus infinity, keep traveling. If there is any probability to accumulate and keep it with you. Okay. So as you travel, there is nothing to accumulate here. There is nothing to accumulate here. At 1, there is something to accumulate 1 by 3. You are keeping 1 by 3 with you. 1 by 3 with you. Okay, let's say 1 by 3 rupees you are having. And as you travel, at 2, there is something more to accumulate. So 1 by 3 plus 1 by 3 is 2 by 3 you have accumulated. And whatever you have accumulated, you are keeping it with you. And at 3, there is something more to accumulate. You have accumulated. And after that, there is nothing more to accumulate. Because the result has become 1. So the total probability is 1. So as you keep accumulating, at some point, the accumulated value will become 1. And once the accumulated value becomes 1, after that it will stay constant. Correct or not? Why? Because the property of PDF is, as you keep adding, the total probability will become 1. So in CDF, what we are doing is we are adding up the probabilities. As you keep adding up the probabilities, at some point, after some value of x, the CDF value will become 1. At least at infinity, it will become 1. In this case, after 3 it is becoming 1. For other random variables it will become 1 after some value of x, but definitely at infinity it will have a value of 1. So what is the value of the CDF at infinity? Value of the CDF at infinity, understand this, p of x less than or equal to infinity. So what is the meaning of this? You are interested in all the values of x from minus infinity to plus infinity. So from minus infinity to plus infinity, you are interested in the probability of all those values. If you add up the probabilities of all the values of the random variable, definitely it will turn out to be 1, because there is a property of probability that says total probability is 1. Here we are trying to find total probability only, no? And one more thing, let us understand what is the value of the CDF at minus infinity. Fx of minus infinity means, substitute minus infinity here. We are interested in the value of the random variable taking values less than or equal to minus. Less than minus infinity, there is no value of x which is less than minus infinity, because minus infinity itself is the last value. Okay, so we are interested in only minus infinity value or less than those values. There is no value of x that we are interested in here. So if you find the probability of that value, it will definitely be 0. Okay, so CDF value at minus infinity is always 0. CDF value at infinity is always infinity. Okay, right. So I'll tell I'll revise this once again. When you have CDF, if you want to plot PDF, what should we do? So as you travel from minus infinity, whatever probability you get, you add it up and plot it here. Add it up and plot it here. As you keep traveling, at 1 you're having something, you take it and plot it. And at 2, whatever you get, you accumulate till that point. You accumulate whatever you get. So there is nothing to accumulate here. So that's why it is staying constant. In CDF, if you are seeing constant thing, it means there is nothing to accumulate in that duration. So from minus infinity to 1, there is nothing to accumulate, or the random variable is taking those values with 0 probability. Whenever you're seeing constant region in CDF, it means that those values, the region in which it is constant, in that region, the random variable is taking those values with 0 probability. The random variable is taking those values with 0 probability. See this one? After 2 till 3, which means 2 plus to 3 minus, which means 2.1 to 2.9. Random variable is taking those values with 0 probability. Whenever you see constant, it means the random variable is taking the values in that region with 0 probability. Okay. And whenever you see discontinuity, here, see this one? Staircase you are seeing. There is a discontinuity at 1, 2, and 3. Why are we getting discontinuity? Observe. We are getting discontinuity wherever there is some significant probability. Whenever a particular value of random variable is having some significant probability, only that places we are having discontinuity. So this one, at 1 there is a probability, so there is accumulation suddenly at 1, so that's why there is a discontinuity. There is an accumulation at 2, that's why there is a discontinuity. There is an accumulation at 3, that's why there is a discontinuity. Or the other way of telling is, when there is an impulse in PDF, there will be discontinuity in CDF. See this one? When there is an impulse, that will lead to discontinuity in CDF. Or the other way of saying is, when there is a discontinuity in CDF, exactly at that point there will be an impulse in PDF. Impulse in PDF indicates discontinuity in CDF. Discontinuity in CDF indicates impulse in PDF. For discrete and continuous both. For discrete random variable as well as continuous random variable, these points are same. The properties or behavior of CDF is same for discrete random variable and continuous random variables. Okay. So I'll take one or two more examples so that you'll understand it better. So I'll revise the same points that I've discussed in this slide again with a different example. Okay. So let's take a die experiment. Let's take a die experiment. Okay. So sample space, we know what is the sample space. Sample space is 1, 2, 3, 4, 5, 3, 4, 5, 6. Okay, so let us define the random variable x as x of s is equal to s, or it means you are taking the random variable as the same as sample space values. So what does the random variable take? Random variable takes values 1, 2, 3, 4, 5, 6, and we know the probabilities of those values. Whatever is the sample space, that itself I'm taking as random variable. So that is how I'm defining the random variable. If you want, you can define the random variable as x of s equal to s square. If you define it as x of s equal to s square, then it will become 1 square, 2 square, 3 square, 4 square, 5 square, 6 square are the values taken by the random variable. Okay. Hi Jayant, good morning. Right, so I'm defining the random variable like this. So the intention in this slide, in yesterday's session, I've talked about in detail about random variable, how we define random variable, why we define random variable in particular way. So all those details I've covered in yesterday's session. If you want, you can go through that session. Okay, in today's session, my focus is on cumulative distribution function. Okay, so this is how I define the random variable for a die experiment. Now we know the probabilities of all these values. Probability of all these values is, each value is 1 by 6. We know that much. So let's plot the PDF here, and using PDF, let's plot the CDF. As a function of x. Let's plot the PDF. This is a discrete random variable. Let's plot it. So this is a discrete random variable. The random variable takes values of 1, 2, 3, 4, 5, 6 with equal probability, which is 1 by 6. The random variable takes a value 2 with a probability of 1 by 6. Okay, right. Now this is the PDF. In yesterday's session, we have talked about PDF and all that. In today's session, our focus is on CDF. Let's plot the CDF for this PDF. Capital Fx of x. So let me revise the definition for it. The definition of CDF is capital Fx of x is equal to P of x less than or equal to small x. Or else if you take it as x naught, you can take it as x naught. Whatever is the value here, that is the value here. If it is 2 here, it is 2 here. If it is 3 here, it is 3 here. So the functions, CDF functions value at a particular point, if you want to find, okay, add up the probabilities of all the values of the random variable till that. If you are interested in fx of 2, what is the meaning of it? Add up the probabilities of random variable from minus infinity till 2. From minus infinity to 2. Or you can say from add up the probabilities of the random variable till 2. In the PDF, add up the probabilities till 2. Similarly, if I say 3, add up the probabilities of the random variable from minus infinity to 3. Whatever is the function, CDF function value at a particular point, CDF function value at particular point is accumulated probabilities till that point in PDF. Jayant, this syllabus is not there for EEE for GATE exam. Okay. For GATE exam, it is not there. But for ECE exam also it is not there. Okay. So this is only for ECE students and instrumentation students. This topic is available for ECE and instrumentation students, but this is part of your mathematics syllabus also. The topic that I'm discussing, I'll be discussing in this week, yesterday's session, today's session, and tomorrow's session also. The 3 classes you can EEE students also can attend. The reason is because these topics are available in your mathematics also. In maths, the probability topic is there. In that you'll be learning about CDF and PDF. Yes, so this topic definitely you can also listen. Even this topic is available for other branches also, because this is part of your mathematics syllabus as well. Right, I hope you have understood the meaning of CDF. CDF at a particular point, if you want to find, add up the probabilities in this PDF. PDF has the information of probabilities at every point. Add up all those probabilities to get the CDF value. Right, let us find the CDF from PDF. So as what did I tell you? From minus infinity, just travel. Is there anything to accumulate? Is there any probability to accumulate? There is nothing to accumulate. So if you travel till 1 minus, there is nothing to accumulate. But at 1, exactly at 1, there is something to accumulate. How much is there to accumulate? 1 by 6. Accumulate it and keep it with you. Okay, accumulate and keep it with you. It is 1 by 6. Next, as you travel from 1 to 2, there is nothing to accumulate. If there is nothing to accumulate, the CDF will stay constant. Whenever there is zero probability, in whatever region there is zero probability in the PDF, in that region it will be constant. It will be constant in CDF. Zero probability in a region, constant probability in PDF, CDF. Zero here, constant here. Impulse here, discontinuity here. Next, from 1 till 2 there is nothing to accumulate, but at 2 there is something to accumulate. How much is there to accumulate? 1 by 6. Already the accumulated value is 1 by 6. You are already having 1 by 6 rupees. So you are having one more 1 by 6. You are take that, keep it in your bag. So now how much is there in your bag? 1 by 6 plus 1 by 6 is 2 by 6. Now you are storing them with you. 2 by 6 you are having. Now you are traveling now from 2 to 3. 2 to 3 there is nothing to accumulate. At 3 there is another 1 by 6 rupees. Just add it up. Keep it in your bag. So how much is there in your bag now? 3 by 6. Now from 3 to 4 there is nothing to accumulate. At 4 there is something to accumulate. Keep it in your bag. 4 by 6. Next, accumulated 5, and then at 6, what is the final value? It is 5 by 6 here, and it is 1 here. After 6 there is nothing to accumulate, so the value is becoming 1. The CDF value is becoming 1 after 6 because all the probabilities are included till 6. Total probability has become 1. Once the CDF value has become 1, after that it will not increase or decrease, it will stay constant. CDF function will stay constant after certain value of x. Okay, which value? It depends on the example. In the previous example, because the highest value of random variable that is there with the non-zero probability is 1 or 3. At 3 we are having a probability of 1 bit. After 3 there is no value of random variable which is having non-zero probability. So that's why it is becoming constant after 3. After 3 it has become constant. CDF has become constant after 3. Whatever is the highest value of random variable with the non-zero probability, after that point the CDF will become 1. See here, the highest value of random variable with non-zero probability is 3. So that's why after that point the CDF is becoming 1. In this example, the highest value of random variable that is available here, highest value of random variable with non-zero probability is 6. So that's why after 6 it is taking the CDF is taking a value of 1. After the highest value of highest value of random variable with non-zero probability, the CDF will become 1. Is that okay? I hope you're following. Very good. See here, impulses in the PDF, discontinuities in the CDF. Impulses in the PDF, discontinuities in the CDF. Right. Zero regions in PDF indicates constant regions in CDF. Zero regions map to constant regions, impulses map to discontinuities. Or similarly, constant regions in CDF map to zero regions in PDF. Discontinuities map to impulses in PDF. Discontinuities in CDF map to impulses in PDF. Okay. So next time onwards, whenever you see PDF or CDF, if you see constant regions or discontinuities, from that you can easily guess what is happening in PDF. Okay, but CDF shape need not be always like the staircase waveform. It can be having any shape. If it is an easy shape like this, it is easy to figure out the PDF. Similarly, if PDF is easy shape like this, it is easy to figure out the CDF. PDF and CDF can have complicated shapes also. Okay. Right. One more point let's observe. Is the CDF ever decreasing? Is it possible? Can the CDF be decreasing? Is there a chance? Is there a chance that CDF can be decreasing? Okay. So then I'll show you. See, I've given you some homework questions in yesterday's session based on PDF. Okay. So questions can be asked like this. So these are the questions. These are some models of questions possible in PDF. In today's session, after some time, in another 5 minutes, I'll discuss about questions based on CDF. Okay. So, and the other type of question they can ask is from PDF. See, here we have solved one question. So from PDF, we found the CDF. The other type of question is from CDF, they might ask you to find PDF. Okay. So PDF and CDF, based on PDF and CDF, they can ask us to find the probability of certain values of random variable. Okay. Right. See this one, CDF. Is it ever decreasing? Has it ever decreased? See this one in this graph. It has stayed constant. It has increased, but it has never decreased. Why? Can anyone tell me why the CDF has never decreased? In this graph or in the previous graph, it has never decreased. Not only in these two graphs, in any CDF graph, we will never see a decreasing shape. In CDF, in a cumulative distribution function of any random variable, you will never see decreasing shape. It will only increase as you travel from minus infinity to plus infinity. It will only increase. It will stay constant or it will increase. Stay constant or increase, but no decreasing. Why? Excellent. Why? Because probability is positive only. Probability can never be negative, right? So what are we doing in CDF? To find CDF from PDF, where as we travel from minus infinity, you are accumulating whatever values are there in PDF. And PDF takes only positive values. PDF will never take negative values, right? As you travel from minus infinity, you are accumulating whatever values are there in PDF. And since PDF never takes negative values, if PDF is taking negative values, only then the CDF will become decreasing. Since PDF will never take negative values, so PDF only takes positive values. So as you accumulate these positive values, here we are accumulating only positive values or zero values. Positive values or zero values, no negative values. Since we are accumulating only positive values or zero values, because the probability can be zero or probability can be only positive, it can never be negative. Since we are accumulating either zero values or positive values, see, if when you are accumulating zero values, it will stay constant. When you are accumulating positive value, it will increase. Because there is no negative value to accumulate here, so that's why the CDF function will never decrease. So CDF is a non-decreasing function, or you can also say monotonically. Monotonically means always from minus infinity to plus infinity continuously. It is monotonically non-decreasing. It is monotonically non-decreasing function. Okay, I hope you're following. So CDF is monotonically non-decreasing function because PDF or probability is non-negative. I'm not saying positive, I'm saying non-negative. The meaning of non-negative is it will never be negative. It will never be negative means it can be zero or it can be positive. If I say PDF is positive, PDF is not always positive. Okay, PDF can take zeros or PDF can take positives. So positive and zero together, I'm calling it as non-negative. Okay, right. So that is the understanding. Now let us write the properties of CDF. Okay, let us write the properties of CDF. The first property of CDF is the value of CDF at any point in the graph, or value of CDF function for any value of the random variable. For any value of random variable, the value of CDF. What are the values taken by this? CDF is also accumulation of probabilities. Probability is always non-negative. Okay, probability is non-negative. Since probability is non-negative, CDF is accumulation of probabilities. When you add up the probabilities which are either 0 or positive, definitely accumulated probabilities also will be greater than or equal to 0. So CDF function will never take negative values because CDF is also having information of probabilities only, but information of accumulated probabilities. So that's why it will never take a value which is negative. And how about the highest value possible for CDF? If you see, observe the examples that we have taken. CDF is accumulation of probabilities, and total probability, since it is 1, because the total probability is 1, as you keep accumulating, the value of CDF will never exceed 1, because it is accumulation of probabilities only, and the total probability of PDF is 1. So that's why, since CDF is accumulation of PDF, this will never exceed, its height will never exceed 1. For any random variable, the value of CDF at any point will never exceed 1. So whatever properties I'm discussing here, they are valid for discrete random variable and continuous random variable also. So the value of CDF only lies between 0 and 1. Second point. CDF, previous slide also we've discussed this. CDF is a non-decreasing function, is monotonically non-decreasing function. Monotonically Cdf is monotonically non-decreasing function. So they can ask you a question like this. They'll give you multiple graphs, okay? They will give you multiple graphs and they'll ask you which of these graphs indicate Cdf. When they say that, see which graph is satisfying these two properties. Whichever graph satisfies these two properties, okay, whichever graph satisfies these two properties, okay, one more thing also. What is fx of infinity? What is fx of infinity? Just now we have discussed. The meaning of this is p of x less than or equal to infinity. You are interested in the values of random variable from minus infinity to plus infinity and its probability. What is the probability of all values of random variable? It is definitely 1, right? Very good. So these three properties is, if there is any graph which satisfies these three properties, then you can call that graph as, okay, it is representing cumulative distribution function of in some random variable. Okay, if it is satisfying all these three properties, yes, it is representing CDF. If it is not satisfying any of the at least one of these properties, it is not a CDF function. A function which satisfies these three properties, we can call it as a CDF function. Okay, right. So how about other observations? How about effects of minus infinity? We know that we are interested in the probabilities of values of random variable from minus infinity to minus infinity only. Values of x less than minus infinity, there is no value that we are interested in here because there are no values which are less than minus infinity. So the probability is 0. Okay, right. So let us write once again the meaning of the PDF. So the meaning of this function is p of x less than or equal to x. Just for better understanding, let me call it as x naught. This will be x naught. Whatever is the value here, same is the value here. So what is the meaning of this? We are interested in the values of x from minus infinity to x naught. X naught included, closed bracket. This is open bracket. No, this is also closed bracket. We are interested in all the values of x from minus infinity to x naught. So that is the meaning of this. We are interested in the probability of the random variable taking the values from minus infinity to x naught. Add up the probabilities of the random variable from minus infinity to x naught. That is what we have here. Okay. So how do we find it? Using PDF, how do we find it? So PDF has the information of the probabilities. So if it is continuous random variable, you have to add up the probabilities from minus infinity to x naught. This has probability information and we have to add up the probabilities of the random variable from minus infinity to x naught. So from PDF, I told you in yesterday's session also, from PDF, if you want to find probability, just integrate. From PDF, if you want to find probability, PDF is probability density. It is not probability. PDF has the information of probability density. From probability density function, if you want to find probability, you have to integrate. What should be the limits of integration? When there is an integration, limits should be important. So from probability density, if you want to find probability, just integrate. Okay. So what is the lowest value of random variable that you are interested in? That should be the lower limit. What is the highest value of random variable that you are interested in? That should be the upper limit. That's it. We got it. Similarly, if it is a discrete random variable, you don't need to do integration. You just need to do summation. Add up so if it is discrete PDF, in discrete PDF, probability density function has the same information as probabilities only. If for a discrete random variables, probability density or probability both are same. So probability density function has the information of probabilities only. Whereas for a continuous random variable, whatever is the function value, that is probability density, that is not probability. So to find probability, you have to integrate. So for discrete random variable, if you are talking about discrete random variable, you have to do summation from minus infinity to x naught. The meaning is fine. The meaning of integration or summation is same. It is accumulation or addition. Since if you're talking about continuous random variable, there are too many values to accumulate. So that's why instead of summation, we are using integration. The lower limit will be the lowest value of random variable that we are interested in, and upper limit will be the highest value of the random variable that we are interested in. Is that okay? Right, next. P of x less than or equal to a. What is the meaning of this? We are interested in the values of x less than or equal to A. Is this looking like the definition of CDF? Definition of CDF or CDF value at A also has the same meaning, correct? CDF value at A means we are interested in all the values of the random variable from minus infinity till A, right? This is also indicating the same thing. Next, how about P of X greater than A? So here I'm trying to indicate, so when they ask you some probability questions like this, when they ask you some probability questions like this, how to convert this format into CDF format? That is what I want you to understand here. So see, CDF means X less than, it should be in X less than or equal to some that format. Okay. So what we do is whenever they give you if they're in less than or equal to form, then we can directly express it in using CDF. But if they're in greater than form or range form like this, A less than X less than B kind of form, what we do is we convert this or this into this format. Let's convert. Can we write this as, here we are interested in the values of X from A to infinity, from A not included till infinity, correct? So can we write this as superset? What is a superset? From minus infinity to plus infinity. From minus infinity to plus infinity. From that, let us remove minus infinity to A included. Is that okay? From this total set, shall we remove minus infinity to A? From this total values of random variable, if you remove minus infinity to small a, what remains is what? What remains is A to infinity only, no? Since A is removed, A is closed here. A is removed means it will be open bracket here. Okay. A we are subtracting. If we are subtracting A, in the remaining values, A will not be included. So this 8 comma infinity, I am writing it as minus infinity comma infinity values. Subtracting, you are subtracting minus infinity to A values, then you will get this value. So instead of writing A to infinity, I'll write it as minus infinity to infinity. We're subtracting minus infinity to A. So we are interested in X between minus infinity to plus infinity. See this? X between minus infinity to plus infinity, which is the total probability, minus P of minus infinity less than X less than A, less than or equal to A. Okay. Hi Shubhadeep. Good morning. So how about this probability? The total probability of the random variable is 1 minus, what are we talking about here? We are talking about P of X less than or equal to A. X less than or equal to A, or this minus infinity to A, both are same, which is 1 minus. How about P of X less than or equal to A? It is same as Fx of A. So whenever you are seeing greater than, what you do is write it as 1 minus P of X less than or equal to A. Whenever they give you greater than sign, you can write it as, you're interested in values of X greater than A, write it as 1 minus probability of the values that are not there here. The probability of these values is same as 1 minus probability of the values that we are not interested here. These are the values that we are not interested here. So from 1, subtract the values of values that we are not interested here. Subtract the probability of the values that we are not interested here. Okay. So this, when you are writing it as X less than some value, we can express it using CDF. We can express it using CDF. Next, how about this? Shall we write it as minus infinity to B? These are the values that we are interested. From that, let's remove minus infinity to A. Is that okay? See this one? From assuming B is greater than A, from minus infinity to B, you are removing minus infinity to A. What remains is the values from A to B. So this probability, I'm trying to express it as X less than or equal to B. See this one? This from minus infinity to B values, I'm writing it as X less than or equal to B, and its probability minus these values, I'm writing it as X less than or equal to A. Now it turns out to be, so P of X less than or equal to B means, if you write it in using CDF, CDF value at B is same as this. CDF value at A, this is looking like CDF value at A. So whenever you see its range form, whenever you see this range form, okay, you can express it as CDF value at this point minus CDF value at this point, subtraction will give you this value. When it is greater than, it is 1 minus CDF value at this point. Very simple. Only these three formats you'll be seeing, 1, 2, and 3. Okay. So when they're asking probability values, probability of a random variable, they can ask you in this format or this format or this format. Only these three formats. In this format, it is straightforward conversion to CDF. This format, yes, you can write as 1 minus of this format, 1 minus of CDF you can write. When it is in this format, like A to B, it is like CDF value at this point minus CDF value at this point. So these are very, very important points. So I hope you have understood. So after the session, you can just take this and try to understand the meaning of this and try to express it using CDF. Once you understand, then there is nothing more to it. So you'll be able to solve all the questions based on it. So try to understand these 3 points, 1, 2, 3. Right. So let me take one more example, temperature example, which I've discussed in yesterday's session also. So temperature in Bangalore, let's say the random variable takes the values from 10 to 40. Let's say the temperature in Bangalore is a random variable is defined as the temperature in Bangalore. So it takes the values from 10 degrees to 40 degrees centigrade. Let us assume that it takes these values with uniform probability. 10 to 40 values it takes with uniform probability. Let's assume the probability density function need not be uniform like this. It can be having any shape. Just for easiness of analysis and explanation, I am taking it as uniform PDF. So it is 10 to 40. What should be the height so that the area is 1? The height is 1 by 30. Height is 1 by 30. So see PDF, this is the PDF. I am assuming that the temperature takes 10 to 40 degrees with equal probability. That is the assumption. Using that assumption, I have plotted the PDF. So now let us plot the CDF. CDF is accumulation of probabilities. So earlier we have discussed examples of discrete random variable. In this I am discussing the example of continuous random variable. So let us talk about a CDF here. What is the meaning of CDF? Let us write it. Fx of x is equal to, or fx of x naught is equal to p of x less than or equal to x naught. And how do we write it using continuous PDF? Fx of x. You are interested in the values of the random variable from minus infinity to x naught. You want to find the probability from PDF. If you want to find probability, just integrate. The lower limit is the lowest value that we are interested, and highest value, upper limit is the highest value that we are interested. Dx. Okay. So which is same as integrate this function to get this function. As simple as that. If you know how to integrate, so integrate this function to get this function. So if you integrate from minus infinity to 10, or you can use the basics also. From minus infinity, as you travel, there is nothing to accumulate. There is nothing to accumulate. Till 10, there is nothing to accumulate. So CDF function will have 0 graph only. After 10, there is something to accumulate. From 10 till 40, there is something to accumulate. There is something to accumulate. So definitely from 10 to 40, it will keep on increasing. It will keep on increasing. Okay. So CDF is integration of PDF because it is constant. Since it is constant, the constant is 1 by 30. 1 by 30, if you integrate, it will become 1 by 30x. Correct? So 1 by 30x means it is a straight line with a slope of 1 by 30. With a slope of 1 by 30. Till 40, it will increase. It will keep on increasing. And after 40, there is nothing to accumulate. When there is nothing to accumulate, the CDF will stay constant. Okay. Now after 40, there is no value of random value. There is no value of random variable which takes with a non-zero probability. So that's why the height will become 1. Okay. Fine. That is the example. Right. So these are the homework questions. So you can try these questions after the session. If you can find the answers, you can post it in the comment section. Okay. Right. So that's it, guys, from my side in today's session. We'll meet again in tomorrow's session. Until then, take care. Goodbye. See you again in tomorrow's session.